Hello, this is William from Visual Components. In this video, I'm going to show you how to model a mobile robot, also known as an automated guided vehicle or AGV, using Visual Components 4.1. Before you get started, make sure you are using Visual Components Professional or Premium because you need access to the Modeling tab here. If you want to see examples of mobile robots or AGVs in your eCatalog panel, expand Models by Type and click Mobile Robotics. You can use these components as templates for modeling your own mobile robot or AGV. However, in this tutorial, I'm going to take a somewhat different approach than what you might see in these components. I'm going to show you how to make any component a vehicle using a vehicle behavior and Python script. To get started, clear the 3D world of all components. I'll now go to the Modeling tab. We're going to create a new component that has one box or block feature. I'll now rename the component, so select the root node. Go to the Component Properties panel. I'll now rename the component to be Mobile Robot. And you can now save your component, so go to the Component group, click the Save button, and then in the Save Component task pane, you can click the Save button to save it to file. Now, to make this component a vehicle, it's very easy. Go to the Behaviors drop-down menu here, and then under Miscellaneous, click Vehicle to add that behavior. In the Properties panel, you can see the vehicle only has a name property. That's because you have to use either .NET or Python API to define the vehicle. In this case, we're using Python API, so I will go back to the Behaviors drop-down menu and add a Python script. In our script, we're going to use the onRun event to define the vehicle. We first need the component object of our script, so I'll write comp equals getComponent. I will now use the component object to find the vehicle behavior. I'll write vehicle equals comp.getBehavior. This method allows you to find a behavior by name. Our vehicle has the default name of vehicle. And now let's print that variable. Compile your code, run the simulation and reset it, and check your output panel. A vehicle behavior is a type of VC sim vehicle. You can learn more about this object by going to the Help tab here. And in Help and Reference, click Python API to access its reference guide. In the reference guide, go to the VC sim vehicle topic. And here you can find all the information you need to define and use your vehicle with Python. For example, you can define the acceleration and deceleration of your vehicle, as well as its max speed. Before you define the vehicle, you must call a method of clearMove, which you can see here. This will remove all points from the vehicle's path. It will completely stop the vehicle and allow you to start fresh. Let's do that now. In our script, I'll use the vehicle object to call the clearMove method. I'll now define the acceleration of the vehicle to equal 300 and do the same for deceleration. Set it equal to 300. For the vehicle's max speed, let's live life in the fast lane and use a value of 800. But what do these values mean? If we go back to the API reference, go to the top of VC sim vehicle, you can see this diagram. So whenever the vehicle has to travel somewhere, it will accelerate, reach its max speed, travel, until it reaches a decision point. From there, the vehicle has to slow down or decelerate to either stop or turn and go on to the next point in its path. Once the vehicle reaches the end of its path, it will stop. Let's compile our code, and if we run the simulation, you can see nothing happens. That's because we have not told the vehicle where to go. When you want the vehicle to go somewhere, you have to assign it a vector. Let's reset, and in our script, we'll import the VC vector module. This allows you to create new vectors. Let's now create a point for the vehicle. All right, point equals VC vector. .new. This is the constructor that allows you to create a new vector. Let's use 2000 for the x value and 0 for the y and z. We now have to assign this point to the vehicle. All right, vehicle dot add control point. This method allows you to add points to the vehicle's path, and your argument has to be a vector. Compile the code. Let's minimize some of these panels and our script so we can see what happens. Before we run the simulation, what we expect to happen is the vehicle will travel along the x-axis and then stop at the point. Let's run, and yep, there it goes. And it stops here. When you reset the simulation, you can see the vehicle is no longer at the end of its path. It's back to its initial location. So just be aware of that. The vehicle will not stay at the end of its path when you reset the simulation.